This is another worked solutions video on enlargements. It's designed for my Year 9 and my Year 10 classes. For Year 9, you will do questions 1 up to 23. And then for Year 10, you had some extra work because you're further ahead and you have an extra 10 questions at the end. As with all of these worked solutions videos, take your time to have a look at it. But what I would really like you to do is, once you've watched the video, is to go back and have a second go at the homework. And otherwise, there's no benefit in just seeing some answers. It's good to be able to try again yourself so that we are consolidating. So you know, yes, I now understand enlargements. I appreciate for many of you, this has been new material and it can be difficult when the teacher's not present in the room. So I'm making this time available in the hope that this will be helpful to you. As always, please do send me feedback if this is helpful to you, and perhaps room also for feedback on how we can improve. So quick recap, please. Here we have the questions. You'll notice here that this first one has been done. At the bottom of the screen, it says question feedback. I have a number of students who perhaps they get it wrong and they're confused, and they will write a question there and say, Mr. Kane, the computer must be wrong. But actually, it's more an issue of a misunderstanding, or sometimes the answer is written in a slightly incorrect way. So please do feel free to lead me feedback, and I will see that. And as always, question 2 here, you see I've left a hint. I've said, don't just write that. You see the student here has written 2 to the power 2 plus 6. I can see why they've written that, but we want to see it. We actually want to see a value there. And I've said that there it's 2 to the power 3 squared. It's 2 to the power 3 times 2 to the power 3. What's that? Well, it's 2 to the power 6, but it asks for the value. And question 3, similarly, I've given you a quick reminder there about bounds, how it works. So do look out for those, please. So first 12 questions are numeracy. I'll go quite quickly through those. So question 1, 5 times 5 squared. Well, 5 squared means 5 times 5. So this means 5 times 5 times 5, which we can write as 5 to the power 3. That's what we're looking for. The value is 125, but we write it as 5 to the power 3, just like that. And then this one, 2 cubed all squared. Well, as I said in the hint, that means 2 to the power 3 times 2 to the power 3. Let me show you what that looks like. We write it out. So 2 to the power 3 is 2 times 2 times 2. If we're squaring it, we're multiplying it by the same thing. Like 3 squared is 3 times 3. So 2 times 2 times 2, well, I could write it as 8 times 8 is 64. Then that is 8 times 8, which is 64. And it's a reminder of the importance of reading the question correctly. So I've corrected that, and now it likes it. Number 3, we're finding the upper bound for this length. So to the nearest centimeter. Well, what does that mean? Well, it means how big can the number be, and it still rounds down to 60. I'm going to show you this. So 60.0 would round to 60, the nearest centimeter. 60.2 would. 60.4 would round to 60. But what if you notice what happens with 60.5? That would round to 61. But what about this number? What about 60.49? That would round down to 60. And no matter how many 9s I have there, it's not quite 60.5, and it will still round down to 60. And what we do is we write that as 60.5 even though we know the 60.5 rounds up, because it is so very, very close to 60.5. And when we do error intervals, you'll see a little less than sign on the upper bound. So that's what I'm looking for, is 60.5. And similarly for part B, 96.3 to the nearest tenth. Well, 96.3, 1 would round down, 0.2 would round down, 0.4 would round down. Once I get to 5, strictly speaking, that would then round up to 96.4. But if I did this, that would still round down to 96.3. So what I do, because that is, I write that as 0.5, because that's the maximum it could be, and it's still going to be within that error interval. And I appreciate that is quite tricky. Question 4 is the lower bound. So we're asking ourselves, what's the lowest it could be and still round up to 40? So for example, I know that 39.9 would round up to 40. 39.7 would round up to 40. 39.5 would still round to 40. What if I did 39.49999? That would round down to 39. So my lower bound's easier, it's just that. And then 82.8, 82.7 something, 79 would round up to, 78 would round up to, 77 would round up to, 75 would round up to 82.8. Anything less than that, so 82.74 would then round down to 82.7. So that's what we're looking for. And there we go. We're going to expand these two brackets. Let me write that out in full. So I can write that 2 lots of x plus 7 gives me 2x plus 2 times 7 is 14. 3 lots of x plus 1 gives me 3x. Need a plus there, don't I? And 3 times 1 is 3. And having done that, all I need to do now is to add together the x's. I've got 2 lots of x, and 3 lots of x gives me 5 lots of x. 14 plus 3 gives me 17. So I put that into MathsWatch, and that's what we're looking for. So let's have a look then at question 6. Again, I would do 3 lots of 2x plus 1 and 2 lots of x plus 3. I'm going to do a bit more quickly here for the sake of time. 3 lots of 2x would be 6x. 2 lots of x would be 2x. 6x plus 2x is 8x. 3 lots of 1 is 3. 2 lots of 3 is 6. 3 plus 6 is 9. And then question 7, this is a worded algebra question. And the easiest way to do this, I think, is to draw a little bit of a diagram. So here is my little sketch. And we've got B and C there. So suppose I had 1 bag and 1 carton. Then my total, if I had 1 bag, would be 4 and 10. And that would be obviously 14. If I suppose I had 2 bags and 2 cartons, then my total would be 2 times 4. Not a great times, that is it. And 2 times 10. If I had 3 bags and 4 cartons, it would become 3 times 4, and let's say 4 cartons, 4 times 10. So what do I write it as? I write that T is however many bags I have. Well, that's going to be B times 4, however many bags there are. How many cartons there are is going to be C cartons, however many there are, and 10 in each. But I don't write it as C times 10. B times 4 I write as 4B. And C times 10 I write as 10C, like this. So I notice that the T equals is already there. So submit my answer. And 4B plus 10C, that's what we're after. So then we have Sue has 18 sweets. Tony has 18 sweets. Sue gives Tony X sweets. Sue eats 5 sweets. Tony eats half of his. We want to know what they have. Well, I'm going to work it out. So I'm going to start off with Sue has 18 and Tony has 18. Let me just write that down just so I can keep track of it. We know that Sue gives Tony X sweets, so Sue now has 18 take away X, however many X might be. And Tony will have 18 plus X, however many that be. So if Sue had given him 5, she would be down 18 minus 5 is 13. And then Tony would be 18 plus 5 up to 23. So then we're told Sue eats 5 of her sweets. Well, if she had 18 and she's eaten 5 of them, then we have 18 take away 5 minus X, which becomes 13 minus X. And what about Tony? Tony eats half of his sweets. So Tony had 18 plus X. Well, I need to divide all of that by 2. So going to have 9 plus a half of X. So that is what I should have. That Tony has 9 plus a half of X and Sue has 13 minus X. I'm going to get rid of my working out because I'm only asked to show the final answers. So let's just have a look at that. So when I look at entering the data into my speed, distance, time formula triangle, I can see that speed will be 15 divided by 6. This is a calculator question. So all I need to do then is put into my calculator and I get that my speed should be 2.5. Before I hit submit, I just need to check my units. That's miles and hours. I want speed in miles per hour. So that should be okay. Question 10, however, is a little bit trickier. I've got kilometers, but I've got some minutes here. So again, let's put it into our formula triangle. So here I have put in speed, 80 kilometers per hour in the bottom left. And then my time is 3 hours, 45 minutes. So I have written that as 3 and 45/60ths. It's not 3.45, it's 45 out of 60. Again, it's a calculator question, so to find distance, I'm going to multiply the two of those together. And when I do that, I get an answer of 300. Right, 2 more numeracy questions left. We're going to use Pythagoras. So the idea of Pythagoras is that the square of the biggest side is equal to the sum of the squares of the 2 smaller sides. Let's just sketch this out, shall we? So you'll see here I've written out the equations using Pythagoras. So the left-hand side being hypotenuse is going to be a squared is 5 squared plus 8 squared. This is a calculator question, so I'm going to stick that in my calculator. When I do that, I'm told that a squared is 89. I want to find a, so I'm going to do the square root of 89, and as a decimal, that's 9.43. Well, I'm asked to give it to 1 decimal place, so That's not working for me, is it? That should be 9.43, just goes to 4. Over on this side, 17 squared is 12 squared plus b squared, but in this case I want to have b squared. So I'm going to have to rearrange my equation, take away 12 squared from both sides, so I get 17 squared minus 12 squared, and that is b squared. It's tempting, I know, to just add together 17 squared and 12 squared, just doing the calculations, but actually have to think about what does it mean. If you write out the formula, you can see I have to subtract, not add. So 17 squared minus 12 squared on my calculator gives me 145. So b squared is 145. I need to find the square root of that, and that comes at 12.04, which should simplify to 12.0. And we'll stick that into MathsWatch. And there we go. And then the last of our numeracy questions, work out the length of x. Well, hopefully you can see that is going to be x squared plus 7 squared equals 14 squared. So I can write here that 14 squared is equal to x squared plus 7 squared. And then I know I want to find x. What I have to do is I have to subtract that 7 squared. So I have that written out. So I'm going to work out what is 14 squared minus 7 squared. That tells me it's going to be 147 is going to be equal to x squared. So I want to find the square root of 147. And that works out at 12.12. The one decimal place, that would be 12.1. So let's see how we get on there. And we're done. So that's the end of our numeracy questions. So now we're on to these enlargement questions. And again, with this stuff, it's new material. I'm sorry I'm not there. I have given you obviously MathsWatch clips to look at, and as part of your learning. I've also given you some core bit maths and video clips as well, because sometimes you don't get MathsWatch. It's good having a different person explaining what we do. So my method when doing these questions is to give me ray lines. You'll see the blue dot. I always draw ray lines to show me what it's going to look like. So I'm going to draw a line, use my ruler, from the center of enlargement through each of the vertices on that triangle. So there is one ray line. I'm going to do the same now for the other points. So let's just twist it up. We're going to go along there. And there is my ray line. And then the third point. And again, there is my ray line. Get rid of the ruler. And the reason I'm doing this is that I know that the vertices of my enlargement will lie along these lines. So for example, if I start here at my center of enlargement and I want to do the top one, let me get my pointer pen. I know from here I'm going 2 to the right and 1 up. If it's a scale factor of 3, then 2 to the right and 1 up will be the same as 3 times 2 is 6. 1, 2, 3, 4, 5, 6, and then 3 up. So 2 to the right and 1 up becomes 6 to the right and 1 up. And I'm checking, yes, that should definitely be on my ray line. So there it is there. Here, to get to this point, 2 to the right, 1 down. Well, 2 to the right and 1 down 3 times becomes 6 to the right, 3 down. 1, 2, 3, 4, 5, 6. 6 to the right, 3 down. 1, 2, 3. And again, I am on a ray line, so that's a good sign. And then finally here, it's going to be 1, 2, 3 to the right, 1 down. If I multiply that by 3, 3 to the right and 1 down becomes 9 to the right and 3 down. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 3 down. And my point should be there. So go to my pencil. So what I would do now is I would join up those 3 points and draw my triangle. And so here I draw my triangle on the 3 sides, and that's what we're looking for just here. Okay, question 14. It says to enlarge this shape. Now, there is not a center of enlargement. All we want to do is enlarge it. I'm going to tell you the answer looks like this, and I want to talk about why it is that. If you look at the bottom, if we look here, this has got 2 sides, or 2 squares. This has 1, 2, 3, 4, 5, 6. It has 3 times the length. This one has a height of 1. This is a height of 3. This is a height of 2. This has a height of 6. So if it's enlarged, then all of those corresponding sides should be multiplied by the same amount. Let's skip ahead to question 15. I'm showing an enlargement of a rhombus. I want to find the enlarged rhombus. Well, how do I do that? Well, I know that this is going to correspond with this, that this is going to correspond with this. And ordinarily, I would get my ruler out and I would draw a line from here going through there. I'd draw a line from there going through here, and I would work out where's the center of enlargement, wherever they match. Actually, I can see the center of enlargement is going to be there. And that this here is being expanded from there to there, that this has gone from there to there. And I can work out actually if that was originally 1 length, this is now 2 squares, that was 2 squares, that's now 4 squares, then my scale factor must be 2. What I can work out from there to there must give me something like this, and from there to there must give me something like this. So I can grab my ruler and I can draw that. So for question 16, I'm asked to describe a single transformation. Well, what's it going to be? It could be a translation, could be a reflection, could be a rotation, or an enlargement. Well, I can see that one's obviously bigger than the other, so it's going to be an enlargement. I can work out the scale factor because I can see that this has a scale side of 1, that's a side of 3, which suggests it's going to be a scale factor of 3. Let's double check. That's a height of 2. This is a height of 6. So 2 to 6, yep, that does seem to give me a scale factor of 3. So what do I do to find the center of enlargement? I'll use my ruler and I'm going to join up this point with this point here. And I'm going to draw a trace line and draw it back. I need to expand that slightly, I think, and see where does that line start. So my center of enlargement is going to line somewhere on there. Let's do another point. Let's do, say, from there up to here. I have to make that little one a little bit bigger as well. And if I do that, then I can see that my lines are going to come there at 1, 0. I could do the same thing for here to there, but I don't need to do so. So let's get rid of the ruler. So what is my transformation? It is an enlargement. It's got scale factor, we said 3, and it's got a center of enlargement, and that is going to be 1, 0, remembering that I write that inside brackets. And there we go. So it's moving on. Just skip ahead there. Question 17. We are asked to find the invariant points. If this is enlarged, scale factor 2, 0, 0, well, I'm going to just copy this and show you what it looks like. So if I have a center of enlargement 0, 0, and I enlarge each of these points, this one is going to be here because it's doubled. That's 3, same direction, that's going to be 6. This point here is going to be doubled. It's going to be here. And this one would be 3 along and 3 up, would become 6 along and 6 up, so it's going to be here. But what about this point here? If I enlarge, it's 0, 0 already, it's 0 away. 0 times 0 is 0, or 0 times 2 even is 0. So this point will stay. So my square will end up looking like this. So then the question is, how many points didn't change? And the answer is this point here. This point doesn't change, so therefore it has one invariant point. So here, if I hit 1, and that's what it was looking for. Question 18. Enlarge this triangle by scale factor 0.5 using 3.3, 1 as the center of enlargement. That looks kind of complicated, but we start off as before. We draw first of all 3, 1 to give me a feel for my center of enlargement. And now I'm going to draw my ray lines. So here I've used my ruler. I've drawn my ray lines. So I can see from the center up to this point, it's going to be somewhere along this line here. But I'm told it's a scale factor of 0.5. That's a half. So it's going to be smaller. Even though we're using the word enlargement, it's actually going to be smaller. But let's do that. So if I start off here, to go from there to there is how many? It's 1, 2, 3, 4, 5, 6, 7, 8 along, and 1, 2, 3, 4 up. So 8 to the left and 4 up. If I enlarge that by half, it's going to be 4 to the left and 2 up. So let's go 1, 2, 3, 4 to the left and 2 up. My triangle should be there. Probably a little bit higher than that. Let me just undo that. And 4 to the left and 2 up. If I take this one, going to this point here, that's 1, 2, 3, 4, 5, 6 to the left and 2 down. 6 to the left and 2 down. Half of that is 3 to the left and 1 down. 1, 2, 3 to the left and 1 down. Takes me to there. And then for this point, let's count 1, 2, 3, 4, 5, 6, 7, 8 to the left. 1, 2, 2, that's 2 down. Yep, so 8 to the left, 2 down. So that's going to be 4 to the left, 1 down. 1, 2, 3, 4 to the left, 1 down. And that should be just there. And all I have to do now is use my ruler to draw that triangle. And there is the triangle. There are our ray lines, and that's what we're looking for. So scale factor 0.5 looks a bit different, but the principles are the same. And if you haven't done that, I'm strongly recommending to you, go back to MathsWatch, practice this, get those questions right. Next question, question 19. I want to scale back to 1.5, 4, 4. First thing I do is I'm going to plot 4, 4. And then I'm going to draw my ray lines from here to each vertex on that triangle. I'm going to work out the distance and multiply it by 1.5. And if I do that, I should get an answer looks like this. There's my ray lines. You can just see that if that's got the 2, 2 times 1.5 is a width of 3. If this was a height of 4, then 4 times 1.5 gives me a height of 6, and my triangle does indeed seem to be correct. So for question 20, there is enlargement scale factor 2. There's no center of enlargement. So first thing I'm going to do is I'm going to try and sketch out what's it going to look like when it's doubled in size. When I say doubled in size, I'm talking about doubling it by each side. So let's just sketch that one out. So here I've sketched out my shape. So what was previously 1 is now 2. What was a height of 3 is now a height of 6. And all I have to do is count how many squares do I have. I can see there I've got 5 lots of 4. So it looks like I have 20 squares. The question is, what are my units? If I just stick in 20, I won't get the full marks, and some of you struggle with that. So I'm told it's a centimeter grid. So it's not centimeters, but square centimeters. Each one of those is a centimeter squared, so it should be 20 centimeters squared. And there we go. Question 21. Enlarge this by scale factor -2 with center enlargement 6,7. And again, this one's going to require some grid lines. So first thing I've done is I've plotted my center of enlargement at 6,7. I've drawn my ray lines here to help me see where they're going to be. And now I'm going to start here for each vertex. And this is 1 to the right and 1 up. But I'm told my scale factor is -2. Now, this is a lot harder, a lot more challenging to do. If you have a negative scale factor, it means rather than going from the center that away, we go the other side of the center enlargement. So what would be 1 to the right and 1 up becomes 2 to the left and 2 down. It's going in the opposite direction by a factor of 2. Here, 2 to the right and 1 up. 2 to the right, 1 up would become 4 to the left and 2 down. And again, I use my ray lines because it's really easy to get this one wrong. And so it's worth taking that time just to sketch them. 1 to the right and 3 up becomes 2 to the left and 6 down. 1, 2, 3, 4, 5, 6. I can see them on my ray line. That gives me confidence. And so now I have to draw my triangle just there. So there's my triangle, one side, another side, and the third side. And let's move on. This one is very, very similar. Start off by drawing my center of enlargement, 4,6. There it is. Draw my ray lines through this center of enlargement, and then scale factor of -2 means it's going to be opposite side. So if it's 2 to the left and 1 up, it'll become 4 to the right and 2 down. Now I know some people will say, well, why bother with the ray lines? Let's just work that one out. I find that it's so easy to get enlargements wrong. It's worth taking that time just to draw the ray lines to help me out. And that's what the question should look like. Here's our ray lines. Here's our triangle. And you can see if that was a width of 1, this is a width of 2. If this was a height of 2, this is a height of 4, but it has been turned upside down because it has been enlarged by scale factor -2. And then the last question for my year 9s. Exactly the same thing. We've got a scale factor of -3. 3,3 is center of enlargement. I've plotted that. I plotted this one. I'm going to come and draw my ray lines through here, and through here. I'm going to work out what's going to look like. So if that is going to be 2 up, none along, this is going to become 2 times 3 is 6. 6 down on the other side. and it's going to look like this, and that's my triangle is going to have this impression. And again, you'll see if that's a height of 3, this started off as a height of 1. If that was a width of 2, this is now a width of 6. So year 9s, I appreciate those last 3 questions were really quite tricky, but then I needed to give you some extension work as well. Please do go back and have a go at that, because I want you to be able to master this material. There's no point sitting in class this time next year and looking at it and saying, well, I have no idea. That's not a way to make progress. You know, practice it. You've got this time available. Let's make use of this time. Obviously, don't just copy my answers, but let them guide you in your thinking. And you may find that going back and looking at perhaps the Corbett clips will then make a bit more sense. With my year 10s, we're going to go on and look at some more work on enlargements and on combinations of transformations. So here, we're told that triangle A is reflected in the x-axis. Well, the question is, where is the x-axis? We know it's going to be here. So first thing I'm going to do is I'm going to translate this to give me B. So if that's my line, the x-axis, I'm going to reflect it. That point is going to go there. This point is going to go 1, 2, 3, 4, 5 up. So 1, 2, 3, 4, 5 on the other side of the x-axis. And this point, 1, 2, 3, 4, 5, 5 up is going to look like that. Now I'm not asked to draw the triangle, so I'm going to just stick with those 3 vertices. I'm told that this is now reflected in the y-axis, which of course is here. So exactly the same thing. This is going to go 2 to the y-axis, 2 to the other side. This is going to go 1, 2, 3, 4 to the y-axis, 4 to the other side. And this is going to go 1, 2, 3, 4, 1, 2, 3, 4, and it's going to look like that. And I'm going to ask myself now, what transformation will move from here to there? And there are actually a couple of different ways of doing this one, because I recognize that I could actually do an enlargement of scale factor -1, but probably the easiest thing is to recognize that this one is this rotated, and I have a rotation in the origin to get from there over to there. And you could perhaps use some tracing paper if you wanted to test that one out. But let's just have a look at that and see. So I think it is a rotation. It's going to be around the origin. That's going to be 0, 0. And I need to give the number of degrees. That's 180. Is there a way of doing degrees here? I think there is. 180 degrees. And in this case, it doesn't matter if it's clockwise or anti-clockwise, you end up in the same place. 25. Part of a shape is shown. We want to complete the drawing of the shape and then rotate it by 180 degrees around the origin. So I'm going to use my ruler very quickly here. It is a reflection. So I can see, oh, that's not quite right, is it? It's going a little bit higher. It's going to look like this. And this is going to look like this. It's quite difficult with MathsWatch in it to get those lines exactly right. And then this point here is going to be, if this point is 2 away, it's going to be there. So I can connect from there to my other corners. That's going to be there. And this one is going to be there. So hopefully if we've done that, we should see that we have a symmetrical shape, and that looks reasonably symmetrical. So now I'm going to rotate that around the origin, and then the easiest way to do that would be to get some tracing paper sketch out the bottom left one, shift it on with the tracing paper, and then sketch out on the top right. And if I do that, my shape should look just like this. Question 26 is a little bit trickier. First of all, I'm asked to find the reflection in the x-axis to give triangle B. So why don't I plot that? This is my x-axis. Let's see what B looks like. Well, this is 2 above, so we're going to have 2 below. I'm just going to sketch this out. Don't need to draw it, just a sketch with the vertices. That's 2 above. This will be 2 below. This is 1, 2, 3, 4, 5 above. This will be 5 below. And so there is my, my triangle B. We're told then it's reflected in the line y equals x. I need to draw y equals x. And I know that it's going to go through the points. Well, let's say I know that when x is -5, it'll go through y is -5. When x is 0, it'll go through y is 0 because they're the same value. I know that when x is +5, y will be +5. So this is my line, y equals x. So just get rid of my ruler there. And I want to draw a reflection. Well, how do I do reflections in diagonal lines like that? The easiest way, you can use tracing paper if you want to. Easiest way I find is to count the squares. If I count up here, 1, 2, 3, 4 up to the line, instead of going the same distance across as I would for an ordinary perpendicular reflection, I actually change direction. So I go 1, 2, 3, 4 to the left. It's going to be there. For this one, I'm going to count up 1, 2, 3, 4, 5, 6 to the right. I'm going to go 1, 2, 3, 4, 5, 6 to the left. And here, let's go all the way up. 1, 2, 3, 4, 5, 6, 7, 8, 9 up to the line. So left 1, 2, 3, 4, 5, 6, 7, 8, 9. And my vertex would be there. All I have to do now is to draw that triangle. And there you can see what it should look like. So that's quite tricky, but guys, you're in year 10. This time next year, you will have written several of your GCSE papers. Time is really, really short, and I want to encourage you, master this material now. Do not leave it until year 11, because we have time now. You will find the pressure is enormous next year, so please take it seriously. So this is a word question. We're told a shape is rotated 180 degrees about the origin, then reflected in the y-axis. We're not told what the shape is. You can basically choose any shape you want and then test it. Now, you could just do a square, but actually I would be inclined not to do a square, because you end up with situations where you think something has been reflected, but actually it hasn't been. So it's worth doing a shape that is a little bit more unusual. MathsWatch is a bit clumsy doing this, so I'm going to do this in a different bit of software. So I'm going to do this. I'm going to make a diagram. Let's do, say, something like this. So I've got a shape there. I'm going to first of all rotate that about the origin. Now I can use tracing paper if I want to, but I can work out, I think, that that is rotated around the origin. And I hope that you can see that that is rotated around the origin. So then I'm asked to reflect that in the y-axis. Well, if I reflect that in the y-axis, it's going to look like this. And so my question is, how did I go from here to here? What single transformation would go from here to here. And I hope you can see that that is a reflection in the x-axis. And so what seemed like a complicated word question actually proves not to be quite as difficult. So let's write it in MathsWatch. Now you obviously could write that as reflection in the line y equals 0, but that's all it wants. So it's that problem solving that's important. Right, question 28. Translate this to give triangle B and then rotate that. Looks complicated, it's not. So first thing I do, I translate. That means 3 to the left and 1 up. Let's go. 3 to the left, 1 up. I have a vertex there. 3 to the left, 1, 2, 3, 1 up. Vertex there. 3 to the left, 1, 2, 3, 1 up. Now, because it's a translation, my new triangle should do exactly the same. That does look like the same size. That's good. I'm then told to rotate it around the origin. So here is my thing. I'm going to rotate that around the origin. I can use my tracing paper. I can see it's going to go there. If I rotate that, I can see that this one's going to go there when I rotate that one, and that this one is going to go up here when I rotate that. So then I'm asked to find a single transformation that will map A onto C. Well, it looks to me like going from here up to here, that's going to be a rotation. We're going to rotate it. It's going to be a rotation probably of 180 degrees. The question is going to be, where is my center of enlargement? And one of the ways of doing that would be to get some tracing paper to sketch this out and see, try different points till I find one that gives me that, that change. And there is your answer. It is a rotation of 180 and it is a center 1.5 minus 0.5. So a little bit trickier. It's actually just here. That's where my center of rotation is. And you'd have to perhaps play a little bit with your tracing paper to work that one out. It's not trivial trying to be able to do that. Now, there are other ways of doing it. You can use some ray lines to guide you, but tracing paper is probably an easier method at this stage. Question 29. We are reflecting A in the x-axis. So again, very quickly, let's have a go at that. In the x-axis, that's 2 above, so it's 2 below. That one's 2 above, so it becomes 2 below. This one is 1, 2, 3, 4 above, becomes, sorry, 4, yeah, becomes 4 below. And there is my triangle B. And then I'm told I'm rotating my triangle B clockwise around the origin. That's a little bit harder to do. So I need to get my tracing paper and it's going to go clockwise. So it's going to end up somewhere over here. So there I've plotted my 3 points using my tracing paper and they're here. And then I'm going to look at this and say, well, what sort of transformation will go from here over to here? And to some extent, you know, you ask yourself, well, what could it be? And, you know, is it a translation? We'll know the shape is different. Is it a rotation? Well, it could be a rotation, except that if I was rotating it, actually, I think I would end up with something like this. It would be that shape rather than this shape. So that suggests that it's not going to be a rotation. Well, what about a reflection? It's not going to be in the x-axis or y-axis. But what about a reflection going that way? And what I would do is I would draw my line and I would try something. I'd say, well, let's just see if I drew that y equals minus x line again. And let's just make it a little bit bigger. Say going from there to there. Would this work? Let's just have a look at that and twist it around a little bit. So there is my y equals minus x line. Does that give me from there to there? If I was to go 1, 2, 3, 4 to the right, to left, 1, 2, 3, 4, that looks good. If I was to go 1, 2, 3, 4, 5, 6 to the left, 1, 2, 3, 4, 5, 6 down. Yep, that looks to me like it is going to work. So I'm going to write it is a reflection in the line y equals minus x. Now that's quite a challenging question, but it is the right answer. Question 30, almost done. This diagram, ABC, is first of all a rotation 90 degrees around C. Let me sketch that one for you first of all. So using my tracing paper, I have sketched out where the first rotation 90 degrees clockwise is going to be. And now I want to get from here to here. And I want to work out how do I do that. Well, I can see that it is bigger. And so because it is bigger, it's going to be an enlargement. But I can also see that the shape looks like it's the other way around, because we have the straight side here, but the straight side over there, which suggests to me it's going to be a negative enlargement. If this is a height of 2 and this is a height of 4, well, ordinarily I would say it was going to be scale factor 2, but because it's the other way around, I suspect it's going to be scale factor of negative 2. So how do I find the center of enlargement? I connect the lines, grab my ruler. Let's join up this point. We know it's going to connect to this point. So somewhere along there, there's my ray line, should be my center of enlargement. And then the question is, where does this one connect? Well, it's tempting to say it will connect to here, but actually I don't think it does, because if it's the center of enlargement, it's kind of turned upside down. I think that this one will connect to here. Let's have a go at that. Starting from here, let's get it right. Going to this one, I draw a line there. Now that suggests that my center of enlargement will be just here, but it's worth double checking, just in case I made a mistake. Let's go from here and connect up the other line. Oops, can't quite reach that one, be a little bit shorter. Go from here, let's connect up the third vertex and see if they do go through the same center of enlargement. Indeed, they do seem to do so. So that suggests to me I have an enlargement scale factor -2, and it's going to be a center of enlargement, and that's going to be 3, 1. Again, that is not a trivial question, but that is what we are looking for. And moving on then to 31. Enlarge this by scale factor -0.5 with enlargement, center of enlargement 3.6. We know how to do this one. So I draw 3,6, which is practicing another one of these. We draw our ray lines through here, through here. We work out -1.5, and it should look like this. So there is my triangle, and that's what I am looking for. Question 32, a little bit trickier and worth having a look at. So I have center -1, 2, -1, 2. There's my center. And here I need to draw my ray lines from each of these points. Let me just do that for you very quickly. So here I've drawn my ray lines. There's 1, there's 2, and there's 3. And in this case, it is a scale factor of negative a third. And that is quite tricky. So negative tells me it's going to be the other side. It's going to be over this side rather than being over this side of our where we start off with. So it's negative a third. So if I go to the left here, 1, 2, 3, that's 3 to the left. My answer will be to the right. The enlargement will be to the right, but it'll be 1 to the right because a third of, it isn't quite right, is it? A third of 3 is going to be 1. So there's my triangle there. If I look at this one, I'm going down 1, 2, 3, 4, 6 down. Well, a third of 6 is 2. I'm going the opposite direction, so it should be just there. And then for this one, I'm going 1, 2, 3 to the left, 6 down. So it should be a third of that, 1 to the right, and 2 up. So my triangle should be these 3 points here. Let's see if we can draw in that triangle. And there it is. So there is our enlargement of scale factor negative a third. Last question. So describe fully the single transformation. Well, what is it? It's bigger. Actually, it's going smaller, isn't it, from A to B? So if it's a change in size, it can't be translation, reflection, or rotation. It has to be an enlargement. So I want to find what's the scale factor. Well, if I look at this one, I can see that this side corresponds to this side. So that is 1, 2, 3, 4, 6 small squares. That's 3 small squares. Going from 6 to 3 suggests to me that that's going to be a half. This one on the top here is 4 small squares. This one is obviously corresponding. It's going to be 2 small squares, and that suggests to me, again, it's going to be a half. Is it going to be plus a half or negative a half? We'll see that in a minute or two. And we want to find the center of enlargement, so we use our ray lines. And I need to make sure I connect like points. So I can tell that this point here is going to correspond to that point there. Make it a bit longer. So I'm going to draw a ray line there and see where we go. Let's have another point that corresponds. Well, I can tell that this point will correspond to this point over here. And so I'll draw a ray line there. Now that does seem to suggest we do have a point there of convergence, but I would want to just check I hadn't made a mistake. So for example, I notice that this point seems to match with this point. So let's draw a line there and see if we get it right. Because it's very easy at this level to make small mistakes with the ruler. So let's just have a look at that. And, oh, now we're a bit uncertain. Where is indeed our line of convergence? Maybe we need another one. Let's go from this point to this point and see if we can work out where is our line of convergence. That's going to go to there. And I can see that indeed my points do seem to be coming together just here. And so that would be 6 along and 5 up. So it looks like we have an enlargement of scale factor. Let's call it SF just for now. Now it is a half, but I notice it's the other side of the center of enlargement. So I'm going to go for minus 0.5 or negative 0.5 and center of 6,5. Just like that. And we'll see if it likes that. And it did indeed. Super. Now that is a challenging question, but I want you to be able to embrace these questions. If that comes up, that's very much a grade 5 question. And to be honest, we should all be looking at those grade 5 questions. So year 10s, thank you for sticking out the last few ones. Please go back, try them again. Use this time. I know the maths is difficult. I know I'm not there, but I want you to be able to make the most of every opportunity to advance your learning. If you find this video helpful, please send us some feedback. If I don't hear from people, then I guess that they're not helpful. So if you want to have some more, then please do talk to me. For now, thank you for this, and happy learning.